All right, boys and girls, this is Math Message 5-3, the main math lesson of the day. And in today's lesson, we are going to learn to recognize equivalent fractions using visual models. But first, let's go ahead and get warmed up. If you have a piece of paper or a dry erase marker, I'm going to have you skip count, but I would like for you to write the numbers on your paper or on your whiteboard as you go. I want you to count aloud by fourths, from 0/4 to 1/4. So let's count together and write them out. So we've got 0/4, 1/4, 2/4, 3/4, and 4/4. Now I'm going to draw this in a picture format. I'm going to go ahead and divide it into fourths. And let's look at what this looks like as we skip count again. So 0/4 would be, remember, if I divide this pizza up into 4 equal parts and 0 are shaded, this is what my circle would look like. And now 1/4 would be 1 out of 4 shaded. 2/4 would be 2 out of 4 shaded. 3/4 and 4/4. All right, let's skip count again. Go ahead and count aloud and write it down on your paper or on your board. Let's skip count by sixths. So we have 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. All right, let's look at that in a picture now. I'm going to divide my circle into sixths. I like to divide it into thirds first, and then divide each of those thirds in half to make my 6 pieces. All right, so let's skip count again. 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. And the last one, let's skip count by eighths. So we have 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. Let's look at that in a picture. So I will draw my pizza here. I like to put a dot in the middle. It helps me divide it equally. Divide it in half, and half again, and each of those in half again. All right, let's skip count again. We've got 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. And hopefully as we were skip counting and looking at those pictures, you kind of started to notice some things that's going to be important as we're looking at equivalent fractions. All right, so go ahead and get your math workbook out, and I want you to turn in your math workbook to page 156. So if you need to pause the video for a minute to do that, go ahead. All right, so the first problem says, Quan ate 1/4 of his pizza and Aiden ate 1/4 of this pizza. So I want you to partition and shade each pizza to show how much each boy ate. So if they each ate 1/4, let's look at Quan's pizza. And how are you going to have to partition this so that you can show he ate 1/4? We're going to have to divide it into 4 equal parts. So go ahead and do that. And if he ate 1 of those fourths, let's shade in 1/4. And then it said Aiden ate 1/4 of this pizza. So go ahead and again divide this pizza into fourths and shade in 1/4. Now Quan said that they ate the same amount because they both had 1/4 of a pizza. Do you agree? And I want you to go ahead and explain in words if you agree with Quan. Do you think they both ate the same amount because they both ate 1/4? Pause the video. And I'm sure you recognize that no, their 1/4 piece is not the same size. And so here's how I explained it in writing, and I'll bet yours is pretty close to what I said. I said, no, that Quan's whole pizza is smaller than Aiden's whole pizza, so Quan's 1/4 is smaller. So even though they both ate 1/4, it wasn't necessarily an equivalent 1/4 because the whole started out smaller. All right, so now let's look down at the next one. It says Laura ate 1 piece of her pizza. So let's go ahead and shade in 1 piece of Laura's pizza. And then Nicole ate 2 pieces of her pizza. So let's go ahead and shade in 2 pieces of Nicole's pizza. Who ate more pizza? And how do you know? Go ahead and pause the video and give yourself time to think and to write. Okay, so again, the question asked you, who ate more pizza? Laura got to eat 1 slice and Nicole got to eat 2 slices of her pizza. So who ate more pizza? And really, the answer is neither. They ate the same amount of pizza. And how do you know that? Because the shaded areas are the same. When we just look at that shaded area, they are the same size. It doesn't matter that Nicole had 2 pieces and Laura only had 1 piece. Their shaded areas are the same. The pizzas were just cut differently, and that's what makes a different fraction. So let's write a fraction showing how much pizza each child ate. Now remember, we've learned about numerators and we learned about denominators, right? I always look at the denominator first. That's going to be like the most important number because the denominator tells you how many total slices. It tells you what the total pieces are and how that pizza is cut. So I know that my denominator for Laura's pizza is 2 because it's cut into 2 slices. Now, remember, the numerator tells me the shaded part. So how much did she get to eat? 1 out of the 2. Now, Nicole's pizza was cut differently. Nicole's pizza was cut into how many slices? Her pizza was cut into 4 slices. Same size pizza. They started out the same, didn't they? Okay, not like Quan's and Aiden's pizzas. These pizzas started out the same. They were just cut differently. Now, how many pieces did Nicole get to eat out of those 4 slices? She got to eat 2 out of 4, or 2/4. Now, these 2 fractions are equivalent, aren't they? 1/2 was the same size as 2/4. So 2/4 and 1/2 are equivalent fractions, as long as the whole started out the same. Okay, let's turn to page 157. We are going to find some equivalent names for fractions. So they gave you some name collection boxes here, and there's in one box you're supposed to make as many fractions as you can that equals 1/2. In number 2, you're going to find as many as you can that equals 1/4. And in number 3, you're going to find as many fractions as you can that equals 1/3. Now, in order to do that, I am going to have you go into your everyday math tools and go ahead and bring up your fraction circles. Now, I'm going to kind of go through here and show you a little bit of what you're going to do, and then you can go ahead and pause the video and kind of work on this a little bit on your own. Remember, it's always easiest to open up a new tab when you go in to open up your everyday math. That way this video can be on one tab, and then you open up a new tab to get into your everyday math. That way you can get into your tools. All right, so the first thing is we're going to find fractions that equal 1/2. So we're always going to pretend for this that this is our whole, and so my half would be one of these pink fraction circles. So I'm going to get rid of the other pink fraction circle, and I'm going to come up with as many different fractions that equals 1/2. Okay, so I'm just going to go ahead and put that. I'm going to bring it to the middle of my screen here. All right, so now I'm going to look down here and see, can I put any orange pieces on here that's going to cover half. And you can see, I'll bring the pink piece over here. You can see that that is not going to work, so I'm not going to use any of my orange pieces. Let's bring up some yellow pieces. Okay, so now bring my half over, and I can see that 2 of those pieces fit exactly with my half. But now what do I call that fraction? What I have to look at is how many pieces would it have taken to cover the whole pizza? It would have taken 4 pieces, right? And how many pieces am I covering to cover half? 2. So my fraction would be 2/4. Okay, so you would draw that onto your fraction circles. And I'll kind of go back here and do that. Now I'm at my desk doing this, so it's going to be a little bit shaky. But I would go ahead and divide that into fourths and go ahead and shade in 2/4. Okay, sorry, it's really bad shading when I'm at my desk doing it. And then I would label my fraction 2/4. Okay, and then I'm going to pick a different fraction. So let's pull up the green ones. All right, I'm going to take, it's always easier to just pull this half piece over. All right, is there anything that fits right on top of that piece? And you can see that there's nothing that's going to make exactly a half with those green pieces. So I'm going to get rid of those. I'll bring up my light blue pieces. All right, can I cover half of that pizza? And yes, I can. I can cover half perfectly. Now, how many pieces? So what would this fraction be called? I can see that this covers 3 of those pieces, but out of how many total pieces? And so you count your total pieces, that's going to be your denominator. So 3 out of 6 is equal to 1/2. So again, you would come over here, you would now divide 1 into 6. Okay. And then you would shade in 3 of them. And then you would name your fraction in numbers. Okay, I'm going to leave the next 2 to you on this one, but I do want to kind of skip down and do a 4th with you, just so, because sometimes doing a 4th is a little bit trickier to look at than a half. So I'm going to go in and I'm going to do the same thing. I'm going to get rid of all these pieces and I'm going to bring up the fourths. All right, this is exactly 1/4 because it took 4 total slices to cover it, and I'm talking about just one of those 4 pieces. So I'm going to get rid of the rest. So I'm just looking at this size. Okay, and again now I'm going to start pulling things up. I'll pull up the orange pieces. Does this fit exactly with my orange pieces? And again, no, it does not. So I'm going to get rid of those orange pieces. I'll bring up my green pieces. I'm just kind of going right in a row here. Does anything fit perfectly into that 1/4 to be the same exact size? And again, it doesn't. So I'm going to pull that down. Now I'm going to bring up my 6, or my blue pieces, sorry. And I'm going to bring this over. Is there any way to make exactly that same size with the light blue pieces? And again, there's not. So I'm going to pull down the blue. They're light blue. Now let's pull up the dark blue. Put my yellow piece on and look there. Do you see? That yellow piece fits perfectly over 2 of the blue pieces. So I know that 2 of these pieces fit on here. Out of how many? Boys and girls, how many would it have taken to cover the whole thing? And 1, 2, 3, 4, 5, 6, 7, 8, right? So 2/8 equals 1/4. Okay, so when I come back here for my 1/4, I'm going to go ahead and make a circle. Again, I'm sorry that this looks so terrible. First of all, I'm going to make 1/4 on here. It'd probably be a good idea to make 1/4, right? And label that. And then I'm going to make another circle. Oops, I should have made those the same size. This is terrible from my desk. I apologize. In fact, that's so bad. I'm just going to get rid of that. Maybe I'll go over to my computer or to my smartboard real quick. That might be a little bit more helpful. All right, so I'm going to draw another circle, try to make it about the same size. This one was divided into 8ths. Okay, and 2/8 is the same as 1/4. All right, now I'm going to give you a hint. There's only one other possibility with the fraction circles that we have available to us. There's only one other possibility to fit in that spot. Okay, and then I'm going to have you go ahead and do the 1/3 all on your own. All right, so you can pause this video, give yourself, it's probably going to take you a few minutes to kind of go through this and get this done. All right, let's go ahead and check your work. So for the 1/2, you should have had 2/4, 3/6, 4/8, and 6/12, and all of those equal 1/2. Now, boys and girls, take a look at this. I want you to actually pause the video and look at these fractions. I want you to see what you notice about these fractions. Go ahead and pause the video. All right, hopefully you gave yourself some time to look at this and think. Did you notice, first of all, did you notice that all of the denominators were even numbers? Did you notice that? And then what did you notice about the numerator compared to the denominator? 2 plus 2 is 4, right? 3 plus 3 is 6. 4 plus 4 is 8. 6 plus 6 is 12. 1 plus 1 is 2, right? The numerator is half of the denominator. That's what makes these fractions equal 1/2. All right, let's look down at our fourths. Here are the fractions you should have had for fourths. Again, we did the 1/4 together. You should have had 2/8, and the other one you should have had was 3/12. And then looking at my thirds, you should have had 1/3, and the only other one you could have made with the fraction circles available on our computer is 2/6. All right. All right, boys and girls, there's actually another practice page that I would like for you to work on just to review. It is on page 158, and it is about areas of rectangles. We've already worked on the areas of rectangles, but I want you to go ahead and do this page as some extra practice. Pause the video, and then I will go over each one very quickly so that you can check your work. All right, let's look at the first rectangle. This is a 5 by 6 rectangle, and the area it would be, remember, you find the length, you find the width, you multiply and write it down. Length times width will give you that area. So 5 times 6 equals 30. So 30 square units. My number sentence would be 5 times 6 equals 30. All right, looking at number 2, this is a 7 by 9 rectangle. I find the length, I find the width, and multiply and write it down, right? So 7 times 9. And if you don't know what 7 times 9 is, you could count all of those. You could skip count by 7, skip count by 9s. We have so many different strategies that you could use for this, but you should have had the area of 63 square units. All right, looking at number 3. This is, now they don't have it labeled for you, but you can just go ahead and count. 1, 2, 3, 4, 5, right? This is a 5 by 1, 2, 3 rectangle. So 5 times 3 equals 15. All right, this is a 2 by 8 rectangle. So 2 times 8 equals 16 square units. Number 5, this is a 4 by 4 rectangle. So 4 times 4 equals 16 square units. And number 6, this is a 3 by 6 rectangle. The area, 3 times 6 equals 18. All right, that is it, boys and girls, for Math Message 5-3.